Hello guys, myself Muhammad Tajuddin from group number 324. I am here to say something about the topic uh, transport process. It's a chapter number 5 in the book Biophysics and Introduction, written by Rodney Cotterill from Danish Technical University, Denmark. So, in transport process, it's mainly deals about the three things: diffusion, viscosity, and thermal conduction. From the basics, movement is a defining character of a living being. So movement depends on the collective behavior of molecule in the liquid. Especially it compared to the human beings, animals, movements are slow in the plants. So first of all, in this chapter, he tells about the diffusion. So diffusion, in 1828, Robert Brown conducted an experiment when he saw a pollen grains in a glass of water. So it is the irregular movement of the pollen grains, the zigzag movement. It named as the Brownian movement. Later, when Einstein proposed, when he released his views about a relative motion, he says that water molecules are moves faster with compared to the solids because it have a small atomic particles. Relative motion especially for the subatomic particles. So it is only applicable for the solids and gases. So for a single particle movement, we create a trajectory, a line for a single particle movement, and we splits that trajectory into small parts in a manner. So total, when we add these small parts, the distance traveled by any substance in any number of units is 0, which means root mean square of a distance is root of its mass. It means R RMS is equal to root m. Therefore, by the time t, the distance traveled by a particle, R is equal to root of d into t, whereas d means diffusion coefficient of a particle. So what are the diffusion coefficient? It is a constant for any other particles like solid, liquid, gases. For a solid, diffusion coefficient is 10 to the power minus 19 centimeters square per second. For a liquid, it is 10 to the power minus 5 centimeters square per second. And for the gases, it is 10 to the power minus 1 centimeter square per the seconds. So from the diffusion, it's a movement. The total influx of a particle is measured by a fixed second law. Fixed second law gives a measurement for the total flux, which is J is equal to half of the BF into C1 minus C2, whereas C1 and C2 are the concentration gradient. This graph shows about the diffusion process over a time. In x-axis, we see the position of a particle. In y-axis, the concentration with respect to the time. So this graph says about the typical behavior of the diffusion, which means from the sharp, when the high concentration, the diffuse turns into a smooth concentration and it becomes uniform movement of the diffusion. So our scientist Rodney Cotterill, in this chapter, he says about the viscosity. When a solid particles subjected into a small shear stress, which is delta, and a shear strain, which is gamma, it will produce gamma is equal to delta by mu. As a solid, it always obeys Hooke's law. In Hooke's law, when the maximum limit of elasticity is reached and it is crossed, the solid substance cannot regain its original shape. It's for about the solid. What about the liquid? From the liquid, Newton derived a relationship between shear stress and shear strain, which is dr by dt, which is equal to alpha into delta, which is equal to delta by pi. Liquid, Newton derived a relationship between shear stress and shear strain. It's for a liquid. It says that dr by dt is equal to alpha into delta. And about viscosity, V is equal to eta by P, where viscosity of a water at 20 degrees Celsius is 1 into 10 to the power minus 3 Newton second per meter square. Therefore, for both liquid and a solid, there is an equation which is change of gamma with respect to time according to Hooke's law, which is equal to change of gamma with respect to time according to Newton law, which is dr by dt in Hookean law. It is equal to dr by dt into Newton's law. So the third part is thermal conduction. Any biological substance, its conduction heat. So law of thermodynamics states that rate of heat transfer is across a given area. In a particular area, rate of a heat transfer is directly proportional to the temperature gradient, which means higher temperature to lower temperature, which is equal to dq by dt is directly proportional to dt by dx, where to change the proportionality we have add a constant which is dq by dt is equal to minus k into dt by dx, where q is equal to heat and t is equal to temperature and x is equal to area, where minus k refers to the decreasing in the temperature and k refers to the coefficient of thermal conductivity. That's all. Thank you.